Welcome. In this notebook, we will review C++ basics. Here's what we'll cover. We'll guide you through everything a beginner needs to start programming in C++ and prepare for real-world software development. We begin with setting up your environment and writing your first program. Then we explore fundamental concepts like data types, variables, and input and output using standard streams. You'll learn about operators and how to control the program flow with conditions and loops. We'll dive into functions, arrays, and strings. A major focus will be on pointers, a powerful but often confusing topic. We'll cover how pointers work, pointer arithmetic, their relationship with arrays, and how they're used in function parameters. Next, we'll explore references, another important feature in C++. And finally, we'll learn how to work with dynamic memory, using both modern and legacy techniques. Each concept is broken down clearly and supported by examples so that you can follow along confidently.
Installing a C++ development environment.
In this section, we'll get your C++ development environment up and running. First, you need an IDE or text editor. Popular choices include Visual Studio, CodeBlocks, or Visual Studio Code. These tools help you write and manage your code easily. Next, install a C++ compiler. On Windows, MinGW provides GCC, which is a commonly used compiler. Mac users can use Clang, while Visual Studio comes with Microsoft's compiler. Sometimes, you'll need to set environment variables to let your system recognize the compiler. Most IDEs handle this for you, but it's good to be aware. Finally, create your first C++ project or file. You're now ready to write and run your first program.
C++ setup and hello world.
Let's now write your first C++ program. The basic structure starts with the main function. This is where your program begins. We use #include iostream to include the standard input-output stream library. This allows us to use std:\cout, which is used to print text to the screen. Type out the code, then compile and run it using your IDE or a terminal. You should see the words "Hello World" displayed. Congratulations! You've just written your first C++ program.
Data types and variables.
In C++, data types define the kind of data a variable can hold. The most common types are int for integers like 5 or -42, float, and double for decimal numbers. Double offers more precision. Char stores a single character like A or Z, and bool is for true or false values. Each type has a specific memory size. You can use the size of function to find out how much memory a type uses. Choosing the right data type is important. For example, use float or double when you need decimals and int when you only need whole numbers.
Declaring and using variables.
In C++, variables must be declared with a type before they can be used. The syntax is type, then name, then optional value. For example, int score equals 90. This creates an integer variable named score with the value 90. Always use meaningful names so your code is easier to understand. For instance, use temperature instead of just X. C++ is a statically typed language, which means each variable's type is fixed. You can't assign a decimal value to an int variable or a string to a bool. This helps catch bugs early.
Type modifiers and constants.
C++ offers type modifiers that extend the behavior of base types. For example, short and long change the size of int, while unsigned removes the ability to store negative numbers. When you want a variable whose value never changes, use const. For example, const double pi equals 3.14. Now pi cannot be changed later in the program. Constants are useful for fixed values like mathematical constants, configuration limits, or anything that should remain unchanged.
Input and output.
In C++, you use cout to display messages on the screen. To send output to cout, use the less than operator. To get input from the user, use cin and the greater than operator. To move to a new line, you can use endl or \n. Endl also flushes the output stream. By default, cin reads input only up to the first space, so if you enter John Smith, only John is stored. To read a full line, including spaces, use the function getLine. When you mix cin with getLine, the leftover new line character from cin might cause problems. To fix that, insert the line cin.ignore before calling getLine.
Arithmetic operators. Assignment operators.
This page shows two tables. The first one lists arithmetic operators. Use plus for addition, minus for subtraction, star for multiplication, slash for division, and percent for modulus. Each operator is shown with an example and the result. The second table shows assignment operators, like equals, plus equals, and so on. For example, x plus equals 2 means x equals x plus 2. These are handy for updating variables quickly.
Comparison operators. Logical operators.
This page shows two tables, one for comparison operators and one for logical operators. In comparison, double equal means equal to. Exclamation equal means not equal to. You also have less than, greater than, less than or equal to, and greater than or equal to. These return true or false. The second table explains logical operators. Double ampersand is logical and. It returns true only if both conditions are true. Double vertical bar is logical or. It returns true if at least one condition is true. Exclamation mark is logical not, which reverses a condition.
Control statements.
In this section, we will explore control statements in C++. Control statements allow us to make decisions, repeat actions, or jump to other parts of the code. There are three main types. First, conditional statements like if else, else if, and switch, used for decision making. Second, looping statements such as for, while, and do while, used to repeat code. And finally, jump statements like break, continue, and return, which control how loops and functions behave. In the next slides, we'll look at each in detail with examples.
If else, else if.
This is an example of conditional statements using if, else if, and else. We check if x is greater than 0, equal to 0, or less than 0. Only the matching block is executed. In this case, x is 10, which is positive, so the program prints the word positive.
Switch statement.
The switch statement is great for checking a variable against fixed values. Here, the variable day is equal to 2. The program matches it to case 2 and prints the word Tuesday. Don't forget to use the break statement after each case, or execution will fall through.
Common loops in C++.
C++ supports three kinds of loops. The for loop is used when you know how many times to repeat. The while loop checks the condition before each repetition. The do while loop checks the condition after running the block at least once. In all three examples, numbers 0 to 2 are printed.
Jump statements.
Jump statements control how loops behave. Break exits the loop completely. Continue skips the current iteration and moves to the next. In this example, when I equals 3, continue skips printing it. When I equals 4, break stops the loop, so the output is 0, 1, 2.
Functions. Function declaration, definition, and calling.
In C++, a function has three parts. First, the declaration. This is also called the prototype. It tells the compiler about the function's name, return type, and parameters, but does not include the body. Second, the definition. This is where we write what the function does. Third, the function call. This is how we use or trigger the function in our program. In this example, we declare a function called add that takes two integers. Then we define it to return their sum. Later we call the function with the numbers 3 and 4, and the result is 7.
Function parameters and return types.
Functions can return any type of value. If a function does not return anything, we use the word void. Parameters are the inputs a function needs to do its job. To send a result back, we use the return keyword. In this example, the function greet returns nothing and simply prints hello. The function square takes an input and returns its square. When we call square with 5, it returns 25.
Default arguments.
In C++, you can assign default arguments to function parameters. This means that if the caller doesn't provide a value, the function uses the default. In this example, the function greet takes a name. If a name is passed, like Alice, it prints hello Alice. If no name is passed, it uses the default, guest, and prints hello guest. Default values must be set in the declaration or definition, but not both.
Inline functions.
Inline functions are useful for small and frequently used functions. When a function is marked inline, the compiler tries to replace the function call with the actual code body. This avoids the overhead of a real function call and can make your program slightly faster. In this example, the function square is declared as inline. When we call it with 4, the compiler will insert the expression 4 times 4 directly. The result printed is 16.
Arrays. One-dimensional array.
A one-dimensional array in C++ is a fixed-size collection of elements of the same type. You define it using the type, followed by the array name and size in square brackets. For example, int numbers bracket 5 defines an array of 5 integers. To access or modify an element, use its index, starting from 0. Here, numbers at index 0 is 10. We change index 2 to 99, and it prints as expected.
Two-dimensional array.
A two-dimensional array works like a table with rows and columns. You define it using 2 sets of square brackets, one for rows and one for columns. In this example, matrix has 2 rows and 3 columns. To access the value in the first row and second column, we write matrix bracket 0 bracket 1. It gives us the number 2. Matrix bracket 1 bracket 2 gives us 6.
Basics of strings using char arrays.
In C++, the basic way to store text is using character arrays, also called C-style strings. A string in this style is simply a char array that ends with a special null character, written as \0. You can declare a string like this: char name bracket 10 equals double quote Alice, double quote. C++ automatically adds the null character at the end. You can also get input using sin and print it using count. In this example, we read into MSG and then print it. Keep in mind, sin reads only one word. It stops at the first space.
Pointers. What is a pointer?
A pointer is a variable that stores the memory address of another variable. To declare a pointer, use the asterisk symbol, written as star. To get the address of a variable, use the ampersand symbol, written as and. In this example, the variable x has the value 10. We create a pointer named ptr and store the address of X in it using AND X. Printing PTR will show the memory address where X is stored, like 0x61FE1C. This address may look different on your computer.
Dereferencing a pointer.
To dereference a pointer means to access the value stored at the memory address. We do this using the star symbol before the pointer name. In this example, star PTR gives us the value of X, which is 10. We can also change the value at that address. By writing star PTR equals 20, we change X itself. So printing X now gives us 20. Dereferencing lets us indirectly read or change values in memory.
Null pointers and safety.
When a pointer doesn't point to any memory, it's called a null pointer. In modern C++, we use the keyword null pointer, written as nullptr. Dereferencing a null pointer will crash your program. To be safe, always check if the pointer is not null before using it. In this example, the pointer is set to null. We check with an if condition. Since the pointer is null, the program prints pointer is null.
Void pointer.
A void pointer is a special pointer that can store the address of any data type. You declare it as void star. In this example, we create an integer called num with value 42. We store its address in a void pointer called ptr. But we can't use star ptr directly. It causes an error. Instead, we must first convert it using a typecast, like star open parenthesis int star close parenthesis ptr. This tells the program to treat the pointer as an integer pointer. Then it prints 42 correctly.
Constant pointer.
There are two ways to use the word const with pointers. If you write int star const p, the pointer cannot point to a different variable, but you can still change the value it points to. In our example, p1 points to a. We can change the value at a using star p1 equals 15, but p1 equals address of b is not allowed. Now look at the second pointer, const int star p2. This means the pointer can point to different addresses, but the value at the address can't be changed. So p2 equals address of b is allowed, but star p2 equals 20 is not allowed. This is useful for read-only access.
Pointer to pointer.
A pointer to pointer means a pointer that stores the address of another pointer. You declare it with two stars, like int star star. In this example, x holds 100. P is a pointer to x. pp is a pointer to p. Printing x gives 100. Star p gives 100 because p points to x. And double star pp gives 100 because pp points to p and p points to x. This is often used in dynamic memory and when dealing with arrays of pointers.
Function pointers.
A function pointer lets you store the address of a function and call it indirectly. It's declared using the same return type and parameters as the function, inside parentheses. In the first example, fptr is a pointer to the greet function. We call it by writing fptr, open parentheses, close parentheses, and it prints hello. In the second example, adder is a function pointer that takes two integers and returns an integer. We assign it the address of the add function. Calling adder with 2 and 3 returns 5. Function pointers are used in callbacks and flexible interfaces.
Pointers and arrays.
In C++, arrays and pointers are closely related. When you use the name of an array, for example, ARR, it behaves like a constant pointer to the first element in memory. That means accessing element 0 using ARR bracket 0 is the same as writing star open parenthesis ARR plus 0 close parenthesis. In the same way, ARR bracket 1 is equal to star open parenthesis ARR plus 1 close parenthesis in the example. we define an array with the values 100, 200, and 300. We first print the value at index 0 using array syntax, and it gives 100. Then we print the value using pointer syntax, ARR plus 1, and it gives 200. Next, we create a pointer called p and assign it to ARR. Then, star, open parenthesis, p plus 2, close parenthesis, gives us 300. This shows how pointer arithmetic can be used to access array elements, just like index notation.
Pointer arithmetic.
In C++, pointers support arithmetic. That means you can use plus and minus to move across memory locations. For example, if you add 1 to a pointer to integer, it moves to the next integer, not just by 1 byte, but by the size of an integer. This is important. Pointer arithmetic respects the data type size. In this code, we have an array with values 10, 20, and 30. We point to the first element using a pointer called p. Then, star p gives us 10. Star open parenthesis p plus 1, close parenthesis, gives us 20. And star open parenthesis p plus 2, close parenthesis, gives us 30. We are moving across the array using pointer math. This works with arrays of other types too, like float or char. The step size changes based on the type.
Pointers and function parameters.
In C++, you can use pointers and function parameters to directly modify values outside the function. This works because you pass the memory address to the function. Inside the function, you use the star symbol to access and change the value at that address. In this example, we have a function called update that takes an integer pointer. Inside the function, we use star ptr equals star ptr plus 10 to change the value. Then, in main, we call update and pass the address of a using the ampersand symbol. After the function runs, a is changed from 5 to 15.
References. What are references?
In C++, a reference is like a second name for a variable. When you change the reference, you are actually changing the original variable. You declare a reference using the ampersand symbol. For example, int ampersand ref equals a. This means ref refers to the same memory as a. In this example, we set a to 10. Then we create a reference called ref that refers to a. When we assign 20 to ref, it also updates a. So printing a gives 20.
References versus pointers.
Let's compare references and pointers. A reference is declared with the ampersand symbol. A pointer is declared with the star symbol. References must be initialized, but pointers don't have to be. Pointers can be null, but references cannot. You can reassign a pointer to point somewhere else, but a reference always stays tied to the variable it was created for. To access the value of a pointer, you use the star symbol, star pointer, but with a reference, it's automatic. No extra syntax needed.
References in function parameters.
References are very useful in function parameters. Instead of copying a variable, you can pass it by reference to avoid performance issues. This also allows the function to modify the original variable. In this example, we define a function called update that takes an integer reference. It adds 5 to the number. We call update with x, which is 10. After the function call, x becomes 15.
Const references.
A constant reference is a reference that cannot change the original value. It is useful when you want to pass variables to a function without copying, but also without modifying. In this example, the function printValue takes a const int reference. You can even pass it a literal, like 42, and it works. Because it is constant, the function is not allowed to change the value.
Dynamic memory allocation. Basics of dynamic memory allocation.
In C++, dynamic memory allocation allows you to reserve memory while the program is running instead of at compile time. To allocate memory dynamically, we use the keyword new. For example, if you write int star ptr equals new int, it reserves space for one integer on the heap and gives you a pointer to it. You can then store a value at that memory location using star ptr equals 42. But unlike automatic variables, this memory is not freed automatically. So you must use the keyword delete to release the memory once you're done. In this case, we call delete ptr. Forgetting to delete dynamic memory leads to memory leaks, which can slow down or crash your program, especially in large applications.
Memory leaks.
A memory leak happens when a program allocates memory using the new keyword but never releases it with delete. Imagine you write int star ptr equals new int and store a value in it. If you forget to call delete ptr, that memory stays reserved until the program ends. Worse, if the pointer is lost or overwritten before you delete it, you can't free that memory at all. It's stuck. Over time, these forgotten memory blocks add up. In long-running programs, this can cause your computer to slow down or even crash. To avoid memory leaks, always make sure every new has a matching delete. There are also tools like Valgrind that help find memory leaks by analyzing your code while it runs.
Dangling pointers and double deletion.
A dangling pointer is a pointer that still points to a memory location that has already been freed. For example, let's say you write int star ptr equals new int, and later you call delete ptr. If you try to use ptr after that, it's pointing to memory that no longer belongs to your program. That's called undefined behavior, and it can lead to crashes, corrupted data, or random bugs. Now, another issue is double deletion. This happens if you call delete on the same pointer more than once. Doing this can cause the program to crash or damage the memory management system inside your app. The best practice is simple. After calling delete, always set the pointer to null pointer. That is, null pointer. Trying to delete a null pointer is completely safe in C++. The program simply does nothing. So remember, delete, then set to null pointer, and never delete the same pointer twice.
Malloc free versus new delete.
In C++, you can manage memory using either the traditional C functions, malloc and free, or the modern C++ operators, new and delete. Let's compare them. Malloc stands for memory allocation. It returns a void pointer, meaning it doesn't know what type of data you'll use it for, so you have to manually cast it to the right type. Also, malloc does not call constructors, and free does not call destructors. That means object initialization and cleanup must be done manually. On the other hand, new allocates memory and calls the constructor automatically. It returns the correct type and no casting needed. When you use delete, it also calls the destructor if necessary. Another difference is how they behave on failure. Malloc returns a null pointer if it fails, while new throws an exception, unless you use a special no-throw version. In modern C++, it's best to use new and delete, or better yet, smart pointers.
Thanks for watching.